Very good morning to all of you and a very warm welcome to Baiju's Exam Prep IS. Parshuram, good morning. Very good morning to all of you. Good morning, Sushmita. Good morning, Ananya. Good morning, Jayant. Very good morning, Himanshu. Good morning, Ranjan. Good morning, Mitali. Good morning, Zainab. Good morning, Subhash. Wish you the same, Subhash. Good morning. Aye, Shabash. Please hurry up, officers. Come on, guys. Hurry it up. Arey wah. Thank you so much, Subhash. You made my day. Thanks, buddy. Thanks. Good morning, Neelkanta. Good morning, Manas. Come on, hurry up. Good morning, Nilab. Good morning, Chandrasekhar. Fine morning, Pooja. Good morning, Archana. Ajao, Shabash. Come on, let's fight for your bright future. And let us utilize this last day of this year. Hmm? Ajo, Shabash, Shabash. Chalo ji. Good morning, Tulasi. Let us start with. All right, good morning, Shivranjani. Let us start with one topic that is called cyclicity. All right, so I hope that everyone is there. And before you actually do that, let me just begin with, you know, some shortcuts here so that we have a good start to the day. Yes, class has started. That's me. Good morning, Hemlata. Aniket, good morning. God bless you, Subhash. Good morning, Dinesh. All right, sir. Let us first of all find out 85 square. All right. Good morning. Good morning. Good morning. All right. 85 square, invariably, you people will be doing it like this, I believe. 5 fives are 25, 2 carry over, 8 fives are 40, plus 2, 42. You put a cross here. 8 fives are 40, 8 eights are 64 and a 4. So it becomes a 68. And then you get a 7, 2, 2, 5. And you also put a line below this. Don't you? Radhe Radhe ji, Harsh. But actually, any number which is ending in 5, for any number which ends in 5, see 85 here ends in 5. Okay. So for any number which ends in 5, if you find out its square, the square will always end in 25. The last two digits will always be 25. So any number which ends in 5, if you want to find its square, the last two digits of the square are going to be 25. All right. Now look at the number or the digit apart from 5. What is the number that we have apart from 5 here? 8. In 85, apart from 5, we have 8. All right. So in counting, what is the next number after 8? 9. So 8 nines are 72 over 72 25. Job done. Get it? It's as simple as that. All right, sir. So I just repeat the process once. For any number ending in 5, for any number ending in 5, 65, 75, 85, 95, 105, 115, or whatever, if you want to find its square is going to invariably end in 25. Now, apart from 5, the digit which is present in 85 is 8. You multiply 8 with the next number in the counting numbers after 8, that is 9. So 8 nines are 72. Just one step followed by 25 is your answer, 7225. Hi Rani, good morning. Good morning Ragini. All right. So very, very fast. I want you people to type and tell me how much is 95 square. Come on, guys. Come on, come on. Let's have a good start to the morning. Come on, come on. Good morning, Aishwarya. Yes, yes, I wish you, Rani. Yes, yes. Come on, guys. Lovely, lovely. So you know that it is ending in 5. So last two digits are 25. 9 when multiplied with the next number after 9, which comes in counting, that is 10, gives you a 90. So 9025, that's it. All right, tell me 65 square, please. Very fast. Come on, guys. Hurry up, hurry up. 65. Oh, lovely. You got this. So 6 sevens are 42 followed by 25. Tell me 75 square. Come on, hurry up. Fast. Come on, officers. Fast. Increase your speed. Lovely. So 7 eights are 56 followed by 25. Lovely. Tell me 105 square. Come on. Hurry up. Oh, lovely. So 10 into 11 should give you a 110 followed by a 25. All right. So tell me for 55 square. Come on, guys. See, we are not using calculators. Orally, within 3 seconds, we are answering the question. We are doing this calculation. Absolutely. So 5 6 are 30 followed by 25. Tell me 45 square. Come on, hurry up. You got this. You got this. Come on, guys. Come on, guys. Hurry up. Hurry up. Get charged up. 4 5s are 20 followed by 25. How much is 35 square? Come on, hurry up. Let's do this. Come on, Shabash. So 3 4s are 12 followed by 25. And similarly, 25 square. Okay. You remember this actually. 2 3s are 6. So followed by 25. So this is the technique for numbers ending in 5, how to find the square really fast. Okay. All right, sir. So we have had a very good start to the day. Let's begin with me giving you an overview of quantitative ability. Let me just talk about the distribution of questions in 2003 paper. Well, number system, there were 21 questions. Now, this is what made it difficult. Okay. Now, way back in 2020 also, there were 20 questions on number system. Thereafter, 2021, 5, 6 questions, 2022, another 7, 8 questions, but 2023 again had 21 questions. All right. So nothing to fear. And then divisibility rules, 3, PNC, 7 permutations and combinations. Cyclicity, 2 questions. Time and work, 1 question. Average is 1. Mensuration is 1. Compound interest is 1. Progressions is 1. So in total, 38 out of 80. So almost half of the paper was based on quantitative ability, that is maths. So you can't leave out any topic. Now, what made the paper of 2023 difficult was that there were so many topics which were left out. If you see 2022, there were questions on, let us say, time and distance. There were questions on some other topics, let us say, like ratio, percentage, profit and loss, So all these topics were left out actually. So that is why, because most of the questions were concentrated only in one topic, and that is number system. Anyhow, so any number of questions can appear from any topic. Any number of questions can appear from any topic. So someone was asking me that how many questions appear from LCM HCF. So usually one question has appeared, but that does not guarantee you that actually only one question will appear next year. No, you might get five questions. Anything can happen. Any number of questions. So once again, number system, as you can see here, 2020 was 20, 21 was 6, 22 was 5, in fact, lesser than the ones that I had quoted. And suddenly 2023, there were 21 questions. Now, similarly, permutations and combinations, you can see in 2018, there was one question, 19 and 20, there was no question. And all of a sudden, there were three questions in 21, eight questions in 22, and seven questions in 23. Look at data interpretation. In 2018, there were 14 questions. 14 questions. And thereafter, only one question, then two questions, one question, and last year, 2023, no question. So anything can happen. Now, in 2020, as you can see, there were 41 questions. 41 out of 80 is more than half. All right. More than 50% of the paper was based on maths. So the distribution could go either way. Now, looking at these topics, I mean, it's not of much use to read them, but then still number system divisibility rules, LCM HCF, we are done. With average, ratio, proportion, we are done. Cyclicity, we'll take up now. Percentages, profit and loss, simple interest, compound interest, mixtures, time and work, pipes and cisterns, time and distance, boats and streams, problems on ages, we have done. Permutation, combination, probability, progressions, mensuration, 2D and 3D, data interpretation, data sufficiency, and simple equations. Well, this happens to be, the longest topic, which we will be doing today, along with divisibility rules. Other topics are small topics, right? So they won't take much time. Actually, each topic would be, completed in half an hour to 1 hour at the most. But yes, number system divisibility rules, and permutations and combinations, because the number of questions were more. So we are going to spend more time on these. Anyhow, let me just start with cyclicity of numbers. Now, that was a topic slated for yesterday, but then it was not completed yesterday. Obviously, we did not touch upon this. We spent more time on LCM. So hence, let's take this up. PNC is permutations and combinations, Rani. Permutations and combinations. All right. Now, please be with me. Focus. Don't look here and there. Don't get involved in any activity. Okay. If at all you're at home, tell people that you're not to be disturbed at all. All right. Now, in cyclicity of numbers, we have to find out the units digit. Now, let me show you the questions here. Okay. See, this is the question you have to solve. In 9 raised to 734, which digit will appear in the units place? Okay. In the following multiplication, which digit will appear in the units place? 2 raised to 89 into 3 raised to 613. All right. 7 raised to 71 into 6 raised to 63 into 3 raised to 65. You have to find out the units place. Okay. 3 raised to 2019 is divided by 10. What is the remainder? All right. Which number is the smallest out of these? Highest. And CSAT 2023, 57242 raised to 9 into 7 into 5 into 3 into 1. All right. Units digit is what you have to find out. This is what we are going to learn today. Okay. So let's have a look at the very basics. Now here, let us find out the cyclicity of all the digits from 2 to 9. What do I mean by cyclicity? What is the units digit for every power of the number? So cyclicity of numbers is used to find the units digit of the power of a number. So you just tell me what would be the units digit here. 2 raised to 1, you know that it is 2. Starting with 2, so 2 square is 4. 2 cube is 8. 2 power 4 is 16. Again, in 16, what is the units place? 6. Again, 2 power 5 is 32. So 32 has 2 in units place. 2 power 6 is 64. so it has 4 in the units place. 2 power 7 is 128, so it has 8 in the units place. And 2 power 8 is 256, so it has 6 in the units place. Now there is something that we notice here. Look at the first 4 powers. Good morning, Sandeep. So look at the first 4 powers. 2, 4, 8, 6. Next 4 powers, units place digits. Again 2, 4, 8, 6. So what do you understand here? You see that after every 4 powers, the units digit is being repeated. See, 2 power 1 is 2. So after 4 powers, here it is power 1. 1 plus 4 is 5. Okay. So 2 power 5 is also 2. See, this is 2 power 2. 2 power 2 is 4. All right. So after 4 digits, sorry, after 4 powers, 2 power 6 also gives you digit 4 in the units place. It is 64, right? So here we can say that 2 has a cyclicity or repetition of units digit, repetition of units digit, repetition of units digit of 4 powers. So 2 has a cyclicity of 4 powers. All right. You can't see my annotation. Well, you need to refresh, Chandra Prakash. You need to refresh your screen then. All right. Now, similarly, let us find out the cyclicity for 3. Okay. So let me find out for 3. 3 power 1 is 3. 3 power 2 is 9. 3 power 3 is 27. So you get a 7 in the units place. 3 power 4 is 81. So you get 1 in the units place. Again, 3 power 5 is 243. Gives you a 3 here. 3 power 6 is 729. So it gives you a 9 here. So once again, what you notice here is that after every 4 powers, the units digit is repeating. See, 3 power 1 is 3. So 4 powers later, that is 3 power 5 is also 3. 3 power 2, units digit is 9. What units digit? It is only a single digit number, correct? So after 4 more powers, 3 power 2, 2 plus 4, 6. So 3 power 6, again you are getting a 9 and so on. So here we find that 3 has a cyclicity of 4 powers. That is, after every 4 powers, you see the same digit in the units place. You see the same digit in the units place. All right. Now let's have a look at 4. 4 power 1 is 4. 4 power 2 is 16. So units place is 6. Only units place digit. That's it. 4 power 3 is 64. So again 4. 4 power 4 is 256. So again 6. So here we find that after every 2 powers, the units digit happens to be the same. So 4 power 1 is 4. So 2 powers later, that is 1 plus 2 is 3. 4 power 3 is also having 4 in the units place. Now similarly, 4 power 2 is 16, right? So 6 in the units place. So once again, 2 powers later, 4 power 4, once again, all right? So it is 256. Again, you get 6 in the units place. So here we find that 4 has a cyclicity of 2 powers. That is, after every two powers, the units digit is repeated, or it is the same. All right. Last digit, Sushmita, not last word. Units digit is always the one on the right hand side. Okay, the one at the extreme right. So let us have a look at 5 and 6. Well, the wonderful thing is any power of 5, 5 power 1 is 5, so ends in 5. 5 power 2, 25, ends in 5. 5 power 3, 125, ends in 5. 5 power 4, 625, ends in 5. So any power of 5, 5 to the power of n, whatever may be the value of n, always ends in 5 in the units place. Now, similarly, 6, any power of 6 always ends in 6 or has 6 in the units place. 6 power 1 is 6, 6 power 2, 36, again 6. 6 power 3, 216, again 6. All right. So we can say here that 5 and 6 have the cyclicity of 1 power. That is, every power is ending in 6. So 1 power change, so 1 to 2 or 2 to 3 or 3 to 4, if these are the values of powers, still 5 to the power of 1, 5 to the power of 2, 5 to the power of 3, 5 to the power of 4, 5 to the power of 10, 5 to the power of 1000, 5 to the power of 1 lakh will always end in a number which has 5 in the units place. So 6 to the power of 1 lakh also gives you 6 in the units place. Okay, moving ahead. Let us have a look at 7 now. So 7 to the power of 1 is 7. 7 to the power of 2. Now keep multiplying 7. No? 7 sevens are 49. So you get a 9 here in the units place. 7 to the power of 3, you must remember cubes, is 343. Correct? 7 to the power of 4, you don't have to remember the powers. 7 threes are 21. 7 to the power of 5. So again, 7 ones are 7. 7 to the power of 6. Again, 7 sevens are 49. So what do you observe here? Well, we observe here that after every four powers, we are getting the same digit in the units place. All right. So 7 power 1, you get 7 in the units place. So write 4 powers later. 1 plus 4 is 5. So 7 power 5 is again giving you a 7 here. 7 power 2 is 49. So 9 in the units place. So 2 plus 4, you get 6. So 7 power 6 is also giving you 9 in the units place. So with this, we conclude that 7 has a cyclicity of 4 powers, right? Okay. So now let us have a look at 8. 8 power 1 is 8. 8 power 2, 64. So you get a 4. 8 power 3, 512, 512. So you get a 2. 8 power 4, 8 twos are 16. So 6. 8 power 5, 8 6 are 48. So again an 8. 8 power 6, 8 8 is 64. So you get a 4. So once again, you can summarize this that the cyclicity of 8 is of 4 powers. Or so as to say, 8 power 1 gives you 8. Then 4 powers later, 8 power 5 also gives you 8. 8 power 2 gives you 4, because 8 power 2 is what? 8 square is 64. So 4 is there in the units place. So 2 plus 4, now we are increasing the power by 4. So 2 plus 4 becomes 6. So 8 power 6 will also give you 4 in the units place. So that means after every 4 powers, these 8, 4, 2, 6, these digits are repeating. Okay. So here we can again conclude that 8 has a cyclicity of 4 powers. Let's have a look at 9. 9 power 1 is 9. 9 power 2 is 81. So you get a 1 here. 9 power 3 is again 9. 9 power 4. Again, 9 nines are 81. So once again, you observe, basically, we observe here that after every 2 powers, the units place digit is repeating. 9 power 1 is 9. So 2 powers later, that is 9 power 3. 1 plus 2 is 3. You still get 9. 9 power 2 is 1. So let us say 2 powers later, that is 2 plus 2 is 4. You still get 1 in the units place. So with this, we conclude that 9 has a cyclicity of 2 powers. Now, you don't need to memorize 2486 and 3971, all these numbers you don't have to memorize, don't worry. You don't need to memorize anything here. All that you need to remember is what is the cyclicity of a digit here. 2, 4, 5, whatever, 2, 3, 4, 5, 6, 7, 8, 9. For these numbers, what is the cyclicity? All right. Now, see, a careful observation here will also tell you that now, see, a careful observation will also tell you that 2 here has cyclicity of 4 powers. Now 3 also has cyclicity of 4 powers. Similarly, 7 also has cyclicity of 4 powers. 8 also has cyclicity of 4 powers. So the numbers which basically have cyclicity of 4 powers are 2, 3, 7, and 8. So 2, 3, 7, 8 are those numbers which have cyclicity of 4 powers. All right. Now let us make some more observations here. Look at 4. 4 has cyclicity of 2 powers. Now similarly 9. This also has cyclicity of 2 powers. Okay. So we can say that 4 and 9, they have cyclicity of 2 powers. And obviously 5 and 6, they have cyclicity of only 1 power. That is it. Now this is something that you must remember. This is something that you must remember. Okay. Now see, it is very important that you remember 2, 3, 7, 8. See, 2, 3, 7, 8. These are also complements of 10. See, 2 plus 8 is 10. Just a way of remembering. Just a way of remembering. And 3 plus 7 is also 10. Just a way of remembering. All right. So 2378 or 2378. All right. 2378 or 2378. Anything that you can call it as. It has cyclicity of 4 powers. This is something that you must remember. All right. Correct, Ankita. 2378 has a cyclicity of 4 and 5, 6 have one cyclicity, and 4 and 9. 4 and 9, they have cyclicity of 2. Yes, 9 and 4 has cyclicity of 2 powers. Correct. SME sir, please help Chandra Prakash. SME sir, please help Chandra Prakash. He is not able to view the screen properly. Chandra Prakash, the only thing is you can log in again. Do log in again. Okay. Or you can just refresh your screen. These are the only two ways. Because no one else is complaining, actually. All right. Okay. All right, guys, let us make another observation here. Let us make another observation here. Look at the even numbers 2, 4, 6, 8. Look at the even numbers 2, 4, 6, and 8 and observe their cyclicity. Well, 2 has a cyclicity of 4 powers. So, in the fourth power, let us say the cyclicity is ending, then 2 power 5 to 2 power 8, the next 4 powers will have same digits in the unit place 2, 4, 8, 6. Then 2 power 9 to 2 power 12, 2 power 9, 2 power 10, 2 power 11, 2 power 12. You will have 2, 4, 8, 6, and so on. All right, so 4 groups, groups of 4, you can say. So the last digit that we have is 6. See, so 2 has cyclicity of 4 powers. So look at 2 power 4. It is ending in 6. It has 6 in the units place. Now, similarly, 4. 4 has a cyclicity of 2 powers. All right. So 4 power 2 is again ending in 6. Look at 6. 6, any power is ending in 6. 8 has a cyclicity of 4. So fourth power of 8 again has 6 in the units place. Okay. So another thing that we learn here is the even numbers 2, 4, 6, 8, they end the cycle with 6. All right. Or so as to say, if you look at the last power of their cycle, see, 2 has a cyclicity of 4. So last power of the cycle is 2 to the power of 4. So 2 to the power of 4 has which digit in the units place? 6. 4 cyclicity is 2. So 4 square is 16. Again, it ends in 6 in the units place. Now 6 power anything gives you 6 in the units place. And 8 has a cyclicity of 4. So 8 power 4 gives you a number which ends in 6. Correct? 6 is there in the units place. So this is what you need to remember, that the numbers 2, 4, 6, 8, their cycle ends in digit 6. Now another observation that we will make here is for odd numbers other than 5. Other than 5, which are the odd numbers that we have here? 3, 7, 9. So see, 3 has a cyclicity of 4 powers. So 3 power 4, it ends in 1. It has 1 in the units place. 7 has a cyclicity of 4 powers. So 7 power 4, it ends in 1. All right. 9 has a cyclicity of 2 powers. So 9 power 2, it ends in 1. So odd numbers apart from 5, because 5 ends in 5. Okay. So apart from 5, the other odd numbers which are there, 3, 7, and 9, their cycle ends in number 1 in the units place. And obviously remaining is 5. 5 will always end in 5 only. Now this is my cloud technology, as you can see. So we have a cloud here. Okay. So these are the two things that you need to remember. So this is important. Please remember these two things. Got it? Lovely. Now I want you to write down these two in your notebook. Please write down these two in your notebook as it is. Please write down these two in your notebook as it is. You have 30 seconds to do that. Please hurry up. And once you are done, please confirm that you are done. Correct, Ankita. Thank you, Rajneet. God bless you. Dipinda done. All right, done. Sushmita, Himlata done. Senab done. Ananya done. Parshuram, please tell me which portion. Last portion means you're talking about the cycle ending in 6, 1, and 5? Do you mean this is what you mean? All right. See, beta 2, 4, 6, 8, if you observe, uh, 2 cyclicity is ending in 4. It has a cycle of 4 powers, right? So 2 power 4 is 6. Okay. Again, 4 cyclicity is ending in 2. Okay. So 4 power 2 is 6 in the units place. 4 square is 16. Similarly, 6 power anything, you will still get 6. And 8 power 4, because 8 has a cyclicity of 4, no? Okay. So 8's cyclicity ends in 4 powers. 8's cycle of units places, it ends in 4 powers. After that, again, the digits will get repeated. So again, it is ending in 6. So that is why 2, 4, 6, 8. These numbers, whatever is their cycle, the last digit or the units place digit at the end is going to be 6. For 379, 3 has a cyclicity of 4. So what do you have? Cyclicity of 4. So we observe that the units place digit is 1. 7 again has cyclicity of 4. So again, we have 1 in the units place, and 9 has a cyclicity of 2 powers. Again, we have 1 in the units place. So 379 will have digit 1 in the units place at the end of their cycle of powers. And 5, as it is, 5 to the power of n is 5. 5 to the power of anything will give you 5 in the units place. I'll tell you how to use it, Dikshit. Wait. No. 379, they are ending with 1. Parshuram. What is the cyclicity of 3? 3 has a cyclicity of 4 powers. So look at the fourth power. It is ending in 1. 3 power 4 is 81. Okay. Now similarly, 7 has a cyclicity of 4 powers. So look at 7 power 4. It gives you a number which ends in 1, which has 1 in the units place. So 9 has a cyclicity of 2 powers. So 9 square is again 81. Again, 1 is present in the units place. So that is why we say 379, they have 1 in the units place of end of their cycle, or that is what, see, simple as that. 3 has a cyclicity of 4, so 3 power 4. What is units place? 1. Now 7 has a cyclicity of 4, so 7 power 4. What do you get in units place? 1. 9 has a cyclicity of 2, so 9 square. What do you get in the units place? 1. Okay. All right. Good. Writing is done. Lovely. Lovely, guys. Lovely. Shall we? Now let me give you some examples here. See, 2 power 34. What will be the units place? We are finding out the units digit. You are not finding out what is 2 power 34. No, you don't need to do that. Now, how do you write 2 power 34? You know that 2 has a cyclicity of 4 powers. Remember, 2 has a cyclicity of 4 powers. See, 2 here has cyclicity of 4 powers. Here, look here. right? We have just mucked it up also. So that means this power, first of all, you will write the nearest multiple of 4. Okay. So write nearest multiple of 4. Which is the nearest multiple of 4 to 34? 32. Yes, you got it. You got it. 32. Correct. Correct. Very good. Very well done. Okay. So now what do I have? I will get 2 to the power of 32. I will tell you why I'm doing it. Why I'm doing it. Okay. Now, how many powers remain? Because out of 34, 2 to the power of 32 will be a cycle of 4, right? 2 power 4, 2 power 8, 2 power 12, 2 power 16, 2 power 20, 2 power 24, 2 power 28, 2 power 32 will have the same digit at the end of the number that is in the units place. And remember, 2, remember this, just a minute. Remember this 2. Let me change the color. Remember this 2. Its cyclicity ends, its cyclicity is of 4 powers, and 2, the cycle ends in 6. Remember, 2, 4, 6, 8, cycle ends in 6. So that is the reason why, 2 power 32, right? This is divisible by 4. So hence we will get a 6 here, because the cycle of 2 ends in 6. The cycle of 2 ends in 6. Even numbers 2, 4, 6, 8. Remember, the cycle ends in number 6 in the units place. Now, what is it that we are left with? 2 to the power of 2. Yes or no? 32 plus 2 is 34, no? Now, what is 2 to the power of 2? Well, it is 4. So here you will get 6, here you will get 4, and 6 into 4 will give you a 24. So in 24, what is the digit in the units place? 4. Okay. So 4 is the digit in the unit place. Okay. 4 is the digit in the units place, and this is our answer. Okay. This is our answer. So now please tell me, A का मतलब yes, B का मतलब no. Let me conduct the first poll of today. Okay, tell me, is this clear to you? Is this clear to you? Fill in A if at all it is clear to you. Rewind, setup. I am not a stereo. Or 85%. So let me explain it again. I'll explain it again. I'm going to take lots of examples. Don't worry. This is the first example. So first of all, what do? You look at the power. Power is 34. 2 to the power of 34. So what do? You first of all look at the number 2. 2 has a cyclicity of how many powers? 4 powers. So first of all, you write down the nearest multiple of 4 to the power that is given in the question. Now in the question, what is the power given? The power given in the question for 2 is 34. Nearest multiple of 4. Why we are taking nearest multiple of 4? Because 2 has a cyclicity of 4 powers. So that is why we are taking multiple of 4. So nearest multiple of 4 to 34 is 32. So 2 raised to 32. Now out of 34 powers, we have taken the nearest multiple of 4, that is 32. Now how many more remain? 34 minus 32, we have 2. What is 2? 34 minus 32. So 2 raised to 32 into 2 raised to 2. This is how we are going to write it. Why are we writing it like this? Because 2 has a cyclicity of 4 powers. So that is why we are expressing the power of 2 as a multiple of 4. Okay, that is, so let me say this is the nearest multiple of 4. Now you know this, if you have seen this, that uh, the cycle of 2 ends in 6. That is 2 to the power of 4. 2 to the power of 4 will have 6 in the units place. Okay. So now see, 2 to the power of 4 units place is 6. So 2 to the power of 8 also is 6. 2 to the power of 12 is 6. 2 to the power of 16 is 6. 2 to the power of 20, you are getting 6. 2 to the power of 24, you are getting 6. 2 to the power of 28, you are getting 6 in the units place. So 2 to the power of 32 also, you're getting 6. So you don't have to do this, obviously. I'm just saying that if the power of 2 is divisible by 4, then you will get 6 in the units place. So 2 to the power of 32, we got 6. Now 2 to the power of 2, 2 square, you already know is 4. Okay. So 2 to the power of 32 will have 6 in the units place. 2 to the power of 2 will give you 4 in the units place. So 6 into 4 will give you 24. That is 4 in the units place. All right. And what is it that we have to find out? Units digit only we need to find out. So 4 will be the answer. Is this clear? No, Shiva, the multiple obviously has to be lesser than the power. Otherwise, I will have 2 to the power of 36 into 2 to the power of minus 2. Why will I do that? See, how will you write 34? Power if it is 32 plus 2, no? Will you write 34 as 36 minus 2? Minus 2 power. Power is negative. Obviously not. Okay, so this is how you write it. Nitin, sir, why multiplying the 6 into 4 when we can unit digit only by 2 into 2 is equal to 4? Only this part is not clear. 2 into 2 is equal to 4. Yes, 2 square is 4. I'm coming to that. Any number that you multiply 6 with, all right, any even number, if you multiply 6 with any even number, that even number only will appear in the units place. See, if you have observed, 6 into 2 is 12. 2, 2. 6 fours are 24. See, 4, 4. 6 six are 36. 6, 6. 6 8 is 48. 8, 8. Obviously, 6 tens are 60. So 0, 0. All right. So actually 6 fours or 24 was not required. You could have directly got 4 here. All right. Now I have not understood, Nitin, why are you writing 2 into 2 as 4? 2 square is 4, that is fine. But then why is it writing 2 into 2 is equal to 4? I'm still not getting that. Hemlata, tell me, what is your problem? Neslins, 2 power 32 is giving you 6 in the units place. All right. And 2 power 2 is giving you 4 in the units place. When you multiply two numbers, all right, when you are going to multiply two numbers, let us say if I give you a number 1, 2, 3, 6, and I'm going to multiply with a number 4, 8, 4. How will you multiply? What is the first thing that you will do? Please tell me. You will multiply 6 and 4. Yes or no? So what is it you get? 6 fours are 24. Then you will carry out the other multiplication. Then what will you do? You will put a cross here. Then you will carry out the other multiplication. Then what will you do? You will put 2 cross here, carry out the other multiplication. And when you add all these, you still get this 4 here in the units place. No? Get that? You get that now? Good morning, Sai. Because the question is, Ankita, the question is, find out the units digit. Look at this. Which digit will appear in the units place? That is a question. The whole topic is based on finding out the units place only. Okay. The topic is about finding out units digit. See here, to find the units digit. This is why we are using cyclicity of numbers. So question will be asked to you to find out the units digit in 2 to the power of something or 3 to the power of something. Okay, that is why we are finding out units digit. Okay, Ankita, it's clear now. Ananya, if we have 2 to the power of 32, then 6 will be the answer. Yes, Ananya, you got this. Very good. Correct, correct, correct. You got this. Shabash. All right. Okay. Now let me ask you another question here. 3 to the power of 89. 3 to the power of 89. Which digit will occur in the units place? Okay. So you want to find out the units digit, the digit in the units place. Okay. What will you do first? The cyclicity of 3 is of 4 powers. You remember? Remember? Yes, correct. You got it. You got it. Many of you got it. Lovely. So you first take the nearest multiple of 4 for 89. Nearest multiple is 88. Correct. Just this much we should do. To find out nearest multiple of 4, you are not going to divide 89 by 4. Huh? So 4 twos are 8 and 4 2 twos are 8. Again, you will do this. You can't do that, no? True. So 3 power 88. This is a multiple of 4. Into how much remains? 3 power 1. Now 3 power 88 should give you 1. Why? Because 3, for 3 the cycle ends in 1. Have you noticed this? Remember? 3. I made you write this in your copy also. 3. The cycle ends in 1. Odd numbers other than 5. 3, 7, 9. Cycle ends in 1. 2, 4, 6, 8. Cycle ends in 6. 2, 4, 6, 8. Cycle ends in 6. 3, 7, 9. Cycle ends in 1. 3, 7, 9. Cycle ends in 1. Bolo 2, 4, 6, 8. Cycle ends in 6. 2, 4, 6, 8. Cycle ends in 6. 3, 7, 9. Cycle ends in 1. 3, 7, 9. Bolo cycle ends in 1. Okay, 5 is 5 anyhow. Got it? Lovely. So what we have here, my child, is for 3 raised to 88, you are getting a 1. Or and 3 raised to 1 is anyhow 3. So 1 into 3 is 3. Many of you did this really fast. Ankita, correct yourself. 4, why did you say 4? Yes, answer is 3. Correct. Now tell me 4 raised to 51. You have to find out the units digit. Okay, now 4 has a cyclicity of how much? 4 has a cyclicity of 2 powers, 4 and 9. Are remember like this, no? 4 and 9 are squares. 4 is a square of 2, 9 is a square of 3. So both have cyclicity of 2. Somehow attach that. So it has cyclicity of 2 powers. So find out the nearest number to 51 which is divisible by 2. Array. So simple, no? 50. What remains? 4 power 1. So 2, 4, 6, 8 cycle ends in 6. 2, 4, 6, 8 cycle ends in 6. So 4 cycle will end in 6. Again, 6 4s are 24. You get 4 as the answer. Lovely, you got it. Okay. Now tell me 5 raised to, now I'm giving you a tough question, all right? 1, 2, 3, 4, 5, 6, 7, 8, 9. What will be the digit in the units place? It's very difficult. It's very difficult actually. I know that. It's very difficult. Sum is 10, correct, Sushmita? Perfect, very good. अरे वाह, इतनी जल्दी! हाउ 50? पूजा, 51 के पास में कौन सा नंबर है जो 2 से डिवाइड होता है? Which number gets divided by 2 near 51? 50 only though, because 4 has a cyclicity of 2 powers. Okay, so 50 is multiple of 2. It is divisible by 2. Got it? All right. Now tell me, 7 to the power of 2, 77. Now listen to me carefully. Listen to me carefully. Listen to me carefully. Okay, let me just revise this a bit. 2 to the power of 1, 2, 3, 4, 7, 7. Okay. Now listen to me carefully. Listen to me carefully. Listen to me carefully. Now this is going to be equal to 7 to the power of 77. Why? 1, 2, 3, 4 we don't require. Why we don't require? Because what is the divisibility rule for 4? Divisibility rule for 4. What is it? Last 2 digits should be divisible by 4. Correct? Get it? So we don't require 1, 2, 3, 4. Okay. So this not required. This last 2 digits required. Get this now. So this is 7 to the power of 77. Now 7, as you know, has a cyclicity of 4 powers. Correct? So first you will write the nearest multiple of 4. So 7 raised to 76. If you don't know, 80 you remember, no? 80 you remember is multiple of 4. 80 minus 4, 76. Huh? So 7 raised to 76 into 7 raised to 1. 379 power ends in 1. 379 power ends in 1. So 7 power 76 ends in 1. This anyhow is 7. So my answer should be 7. अरे वाह, you got it. Dipinder, 4 कैसे आया बेटा? Justin, how did you get 9? Ankita, which part? Huh, last part only, na? See, whatever may be the number given to you, 7 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 7. Because 7 has a cyclicity of 4, now we want to convert it into a power which is multiple of 4. Okay. And what is the divisibility rule of 4? Last 2 digits are required, no? Only last 2 digits are required. So except these last 2 digits, whatever is written on the left hand side, please remove it, ignore it. Not required. Only last 2 digits are required. Okay. So 7 raised to 1, 2, 3, 4, 7, 7 will have the same units digit as 7 raised to 77. Simple. So you have reduced the question now. And 7 raised to 77, because 7 has a cyclicity of 4 powers. So once again, we will write down the nearest multiple of 4. Nearest multiple of 4. Nearest multiple of 4 to 77 is 76. Sir, how do you know, or how do we know to find out 76 so fast? That's what I'm telling you. 80 you know anyhow. Nearest multiple of, you find out a number which is divisible by 4. You know that 40 is divisible by 4, 80 is divisible by 4. If 80 is divisible by 4, then 80 minus 4, 76 will also be divisible by 4. So 7 raised to 76. Now how much remains? 1. Power 1 remains, right? 77, 76 plus 1. So 7 raised to 76 gives you 1. Why? 379 cycle ends in 1. 379 cycle ends in 1. Look at the notebook, the second part which I have given to you. Okay, this one. See, 379 cycle ends in 1. Okay, so this will give you a 1. And 7 power 1 is 7 anyhow. So you will get 1 into 1. 1 into 7, 7. Bless lanes, you were supposed to note it down. I gave you time also, actually. Now take a screenshot of this. Huh? These, this and this. All right. Now guys, let's get started. So just a quick revision. Cyclicity of numbers 2, 3, 4. This is cyclicity is of 4 numbers. 4 powers. Cyclicity of 2 powers. Cyclicity of 1 power. Cyclicity of 4 power. Cyclicity of 2 powers. Remember? With the help of this, I made you the table. Now this is what I told you. Numbers that follow the cyclicity of 4. There are 4 numbers. Which are those? 2, 3, 7, 8. Numbers that follow the cyclicity of 2. There are 2 numbers. Which are those? 4 and 9. And numbers that follow the cyclicity of 1. There are 2 numbers. Which are those? 5 and 6. Right? So this is a quick recap. Now tell me 2 raised to 74. Which digit will appear in the units place? So very fast. Very, very fast. I'm giving you the poll. I want you people to mark the poll, right? Huh? Come on, mark your answers. Mark your answer. All right. 2 power 74. So 2 power 74 can be written as 2 power 72 into 2 power 2. Why 2 power 72? Because this is a multiple of 4. Because this is divisible by 4 and 2 has a cyclicity of 4. This gives you 6. 2, 4, 6, 8 cycle ends in 6. And this gives you a 4. So 6 4s are 24. Last digit is 4. 3 power 67. Be fast. Oh, lovely. You got this. You got this. शाबाशिया. अजीत चेक करो बेटा एक बार. Mark your answer now. Mark your answer. Okay. So 3 power 67. Are you remember, no? 4 cube is 64. Huh? And 3 has a cyclicity of 4. See? Cyclicity of 4 powers. Alright. So it can also be written as 3 power 64 into 3 power 3. Alright. So 64 here is divisible by 4. 4 cube is 64, yeah. Come on. Now 379 cycle ends in 1. 379 cycle ends in 1. Alright. So this anyhow will give you a 1. Now 3 power 3 is 27. 3 cube is 27. So 1 7 is 7 should be your answer here. कोई बात नहीं केतन. Correct, Atish. Correct. Correct. Perfect. Perfect. 4 raised to 81. Now 4 has a cyclicity of 2 powers. So now this time 4 the power that 4 has should be divisible by 2. That is an even number. Even number. Okay, less than 81 is 80. Anyhow, mark your answer. Oh, perfect. You got it. You got it. शिल्पा चेक करो बेटा, एक बार देखो ना, कनकावली, just check no. Perfect. Lessons. How do you get 5? No, not 5, beta. Just check once. Correct. Mark your answers now. Mark your answers in the poll. Come on, hurry up. Come on, guys. Fight, fight. Ah, lovely. What an improvement. So 4 power 81, because it has a cyclicity of 2 powers. So nearest number to 81, which is divisible by 2. Divisible by 2 is even number only, no? So 4 raised to 80 into 4 raised to 1. 4 raised to 80, 2, 4, 6, 8, cycle ends in 6. 2, 4, 6, 8, cycle ends in 6. So once again, 6 fours are 24. 4 should be the answer. Or a very difficult try. 1, 2, 3, 4. Such a huge, large number. No, how to solve this? Very difficult. Please mark your answer. Oh, wonderful. 84%, 16% are still remaining. 5 power n is 5 only, no? Any power of 5, you will get 5 in the units place. Oh my God. 6 raised to 1, 2, 3, 4, 5, 6, 7, 8, 9. Very difficult, man. Come on, officer. If you have that table in front of you, you will be able to solve. Okay, mark your answer in the poll. Mark your answer in the poll. Please mark your answer in the poll. Hurry up, mark your answer. Mark your answer in the poll. Come on, hurry up, hurry up, hurry up. 94%, lovely. So 6 power anything gives you 6. Simple, simple little star. See? 7 raised to 343. What will you get? Well, let me solve this along with you. 7 raised to 343 will have same digit in the units place as 7 raised to 43. Why? 7 has a cyclicity of 4 powers. Right? So find out the nearest multiple of 4. And why is it that I am ignoring this? Because I need only last 2 digits. Why? Because I'm going to divide this by 4. And what is the divisibility rule for 4? Last 2 digits. So this is 7 raised to 40 into 7 raised to 3. Alright. 379 cycle ends in 1. Okay. And 7 cube, you must remember, is 343. It ends in 3. So hence you get a 3 here. Get it? Oh, lovely. You got this. Look at this now. 8 raised to 515. Now 8 has a cyclicity of 4 powers. So 8 raised to 515 shall be 8 raised to 15. That's it. Nearest multiple of 4, 8 raised to 12 into 8 raised to 3. Correct? 2, 4, 6, 8. Cycle ends in 6. Okay. And 8 cube is 512. So you get a 2 here as the answer. शिल्पा बेटा देखो You got this now? 9 raised to 734. Arre. Ambika, first step is nothing. You just have to divide it by 4. Take the nearest multiple of 4. You should know the table of 4. That's the only thing. Okay. So let us practice more. Okay, you'll get it. Just focus. Now, I'm doing this along with you. In the following multiplication, which digit will appear in the units place? So you have 2 raised to 89 into 3 raised to 613. Now, first of all, you know that 2 has a cyclicity of 4 powers and 3 also has cyclicity of 4 powers. So you are going to convert the powers first into a multiple of 4 and then remaining. So I don't require this 6. Okay, we need just last 2 digits. All right, because divisibility rule of 4 says if you are going to divide 613, it is same as dividing 13. So this should be written as 2 raised to, Ambika, tell me 89. Tell me a number which is near to 89 and is divisible by 4. 88, it should strike to you. It should strike to you. Or else what do? 89 you divide by 4. Okay. Then what do you get? 88 only you get, no? 1 remaining. So 89 minus 1, 88 is the number. Okay. So 2 raised to 88 into 2 raised to 1. Here 3 power 13 is 3 power 12 into 3 power 1. 2 power 88, 2, 4, 6, 8 cycle ends in 6. Alright, into 2, 3, 7, 9 cycle ends in 1. So 1 into 3 power 1, 3. 6 twos are 12, so you get 2 here. 1 threes are 3, so you get 3 here. So your answer here should be 6. Oh, lovely. Most of you got it, yeah. Shabash. Lovely, lovely. Most of you got it. क्या बात है? चलो भैया खेला शुरू किया जाए. 7 raised to 71 into 6 raised to 63 into 3 raised to 65. So 7, cyclicity of 4. Nearest multiple of 71. Acha, you remember 80. 80 is multiple of 4, no? 80 minus 4. 76 will be multiple of 4. 76 minus 4. 72 will be multiple of 4. But 72 is greater than 71 now. So 72 minus 4. 68 will be multiple of 4. Otherwise, 4 cube is 64. 64 plus 4, 68. Divisible by 4. So this is 7 raised to 68 into 7 cube. 6 raised to anything is 6. Alright. And 3 raised to 65. 64. Now 3 has a cyclicity of 4. So nearest multiple of 4 to 65 is 3 raised to 64 into 3 raised to 1. So 379. 379. The cycle ends in 1. Okay. And this anyhow 7 cube is 343. So you got a 3 here. You get a 6 here. And this is a 3. Remove the ones. Not required. Okay. 6 threes are 18. Okay. And 8 into 3 is again 24. Right? So your answer here should be 4. Ari, you got this. Now, just tell me, let me just conduct a survey here. Have you understood this? Say yes or no. Did you get the fundamentals? Have you understood this? Please mark the poll. Please mark the poll. Have you understood? Atish, please tell me now which part you want me to explain again. I'll do that. 92%. Lovely. Large yes, Shahid. Kya baat hai? Which part once again, Atish? This complete? All right. 7 raised to 71, 6 raised to 63, 3 raised to 65. 6 raised to anything is 6. You know that, right? 6 raised to n, you get a 6. Now 7 has a cyclicity of 4. All right. 7 has a cyclicity of 4. Well, you just need to remember this 2, 4, 6, 8. Cyclicity ends in 1. 3, 7, 9. Cyclicity ends in 1. 2, 4, 6, 8. Cyclicity ends in 6. And 5, cyclicity ends in 5. So some numbers, they have cyclicity of, so a small revision here, 2, 3, 7, 8, cyclicity of 4. 4 and 9, the two squares have cyclicity of 2, and 5 and 6, they have cyclicity of 1. So if this table is there in front of you, then 7, then what is the problem? 7. Now 7 has a cyclicity of 4 powers. So you should now have a multiple of 4 nearest to 71, which is 68. 71 minus 68, remainder is 3. Okay. So 7 raised to 68. Now here, cyclicity of 7, it ends in 1. So 7 raised to 68 will give you a 1. 7 raised to 3 is 343 cube. So ends in 3. 6 raised to anything is 6. 3 raised to 65. Again, 3 you see has cyclicity of 4 powers. All right. So 65 we are converting into 64 plus 1. Okay, 3 power 64, 64 which is multiple of 4. So 3 power 64. Cyclicity of 3 ends in 1. So it gives me a 1 here. Okay, 3 power 1, anyhow 3. So 7 power 3 is 3. When multiplied with 6, 3 6 are 18. So what do I get here is 8. And 3. If I multiply this 8 with 3, I get a 24. Units place is 4. Get it now? No. 7 has cyclicity of Atish. You have not noted down this table. See, you're asking me irrelevant question. Whose mistake is it? Mine or yours? If you have not noted down this table. And it is written in front of you also. This is cyclicity ends in. This is cyclicity of. So 7 has a cyclicity of 4 powers. And 7's cyclicity ends in number 1. So this is cyclicity of 4 powers. So first you write the power of 7, which is multiple of 4. And then that gives you a 1. Okay. All right. Welcome. Now let's have a look at CSAT 2021. Now this question says 3 to the power of 2019 is when divided by 10. What is the remainder? Hold it. I will make you solve this question. First you answer my question. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 10. All right. What is the number in the units place? Remainder. All right. What is the remainder? What is the remainder? You tell me. What is the remainder? What is the remainder? You tell me. Obviously, it is 9. The last digit is the remainder. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 100. Tell me what is the remainder? Tell me the remainder. Absolutely yes. Remainder is 89, the last two digits. See, 10 means last digit. Two zeros means last two digits. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 1000, three zeros. So what will be the remainder? Tell me. Ah, you got it. 789, the last three digits. So whatever is this number, if it is divided by 10, then what is the remainder? What is the remainder? Obviously, the remainder is going to be the units digit. The remainder here, see, is 9. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 when divided by 10 gives you 9. Correct? So units digit is the remainder. Alright, so ultimately he is asking you 3 raised to 2019, what is the units digit? So what will you do? 3 raised to 2019, first you will write it as 3 is raised to 19. Now 3 has a cyclicity of 4 powers. So 3 raised to 16 into 3 raised to 3. Now 379, cyclicity ends in 1. So 3 raised to 16 should give you 1. 3 raised to 3, 27. So you get a 7 here. Perfect. So many people have answered. Lovely. Got it? So just now you solved a CSAT question. So now we have exponents. See, you've heard of exponents, right? Indices or exponents. You've heard of certain things. All right. So what I want you to know is whether you know this or not, 2 to the power of, let us say 10, you know, is 2 to the power of 2 raised to 5 or 2 to the power of 5 raised to 2. You know this? Yes? Okay. So this is clear to you. Now look at the numbers which are given to us here. 2 raised to 40, 3 raised to 21. Now we are not finding out units digit. We are doing exponents. 4 raised to 18, 8 raised to 12. Out of these four numbers, which is the smallest? Well, 2 raised to 40 remains as it is. But you know that 4 and 8 are multiples of 2. They're multiples of 2. So this I can write as 2 raised to 2 raised to 18. Because 4 can be written as 2 raised to 2. So this becomes 2 and 18 multiplied. This becomes 2 raised to 36. All right, 2 into 18. Now similarly, 8 raised to 12. You know that 8 is 2 cube raised to 12. Again, 12 threes are 36 to 2 raised to 36. And this 3 raised to 21 is as it is. Now kindly see which number will be the smallest. Well, first you compare these three numbers where the base is same. Which will be the smallest? 2 raised to 36. But I can't have two choices as the answer, no. There are two choices which have 2 raised to 36. I can't have 2 raised to 36 as the answer, no. Because these are two choices. Okay. So, can't have two choices as the answer. Okay. So, these two are gone. Now, 2 raised to 40 is not the smallest because 2 raised to 40 is anyhow greater than 2 raised to 36. So, it is not the smallest. So, obviously, even this is gone. So, what is left? 3 raised to 21. Smart work. Correct? Just smart work. Got this, sir? Got it. All right. Now let us have a look at CSAT 2023. So he's straight away asking you what is the units digit in the expansion of 57242 raised to 9 into 7 into 5 into 3 into 1. Okay. Now first things first, 57242. This is to the power of 9 into 7 into 5 into 3 into 1. Now just tell me, this will be giving you a number which ends in 5, yes or no? Because 5 into any number will give you 5 in the units place. So tell me yes or no. 9 into 7 into 5 into 3 into 1 will give you a number which ends in 5, yes or no? Obviously. So it gives you a number ending in 5. Correct? Now this can be directly reduced to 2 to the power of 5. 2 to the power of 5. Is it? Can we do that? Or you want to find this? All right, let's do it. Let's do it. Okay, so let me just find out. Let me just not take this. Okay. चलो निकाल लेते हैं. So 9 sevens are 63 and 5 threes are 15. चलो 15 threes are 45. 15 six are 90. So 945. So now this can be written as 57242 raised to 945. That is what it is written as. Okay. Now, first things first, you want just the last digit, no? The last digit of this number 57242, last digit 2 will be responsible for giving you the units digit, no? Okay, so we will reduce this to 2 to the power of, I want just the last two digits, 45, because 2 has a cyclicity of 4. So the number divisible by 4 requires only the last two digits. So this is going to be 2 raised to 44 into 2 raised to 1. All right. So 2468 cycle ends in 6. So 6 into 2, 12. How 2? 2 is given here, beta. Last digit is responsible. No. It is a last digit which will be responsible for giving you the last digit. Units digit will be responsible for giving you the units digit. Or 5 will give you the units digit. Obviously not. Okay, tell me. 1, 2, 3 into 1, 2, 3. What will you get in the unit space? 9, no. Into 1, 2, 3. Again, 9 threes are 27. So it is only the units digit of this number which is responsible for giving you the units digit. Correct or no? So if you have 57242 into 57242, what will you get here? 4. Okay. Into this is cross and then this, and this is 2 cross and this. So whatever you get here ends in 4. Again, 57242. You will still multiply 4 into 2, 8. So that is why 2 is taken here. Okay. So 2 is raised to 945. Okay. Cyclicity of 2 is 4. So we don't require this 9. We just need the last two digits. So 2 raised to 45. See, 2 raised to 1, 2, 3, 4, 5, 6, 7, 8, 9 will be equal to 2 raised to 89. Just last two digits required. Because it is divisible by, because it should be a multiple of 4. And what is the divisibility rule for 4? Last two digits. That's it. Is this clear? Is this clear? That's what I'm telling actually. And that is what I'm coming to. So directly what you could have done is 2 raised to 5 also you could have got, but that is not the right way. Okay. Because if it is 2 raised to 43, it is same. Because 40 is divisible. Alright. So you could have done that. So directly you could have taken 2 raised to 5. Okay. Which is going to be 2. Again. So either ways. Divisibility rule for 2. No. A number is said to be divisible by 2 if it has 0, 2, 4, 6, 8 in units place. Okay, that is the divisibility rule for 2. Even number, no? Even number will have 0, 2, 4, 6, 8 in the units place. All right, sir. We did it. Did it. Cyclicity. What is the spelling of did it? Did it. Huh? Past tense. So we completed cyclicity. All right. I hope that you people have a good hand at it now. Let me just take a review. Please let me know. Uh, do you think you have a good hold on cyclicity now? With practice, you will be able to solve questions. Yes, practice is definitely required. So please mark the poll. Mark A if you feel yes, you have understood most part of it. Rest is practice. 97%. Lovely. Okay, sir. Now I start with a very important topic, as I told you, number system. Okay. So 21 questions appeared this year. In 2020, 20 questions appeared. So let's catch a good hand over this. Now, what is my requirement out of you? My requirement is this: you should be good at addition, subtraction, multiplication, division. This is my first requirement from you. Second requirement is I want you people to know counting from 1 to 100. You know this? अरे और आता ही क्या है अपने को, है ना? All right. Now I want you to know one basic thing, that 5 into 2 is 10. Okay. And 5 square into 2 square is 100. 25 into 4 is 100. I want you to know that 91 is 13 into 7. I want you to know that you should actually know tables till 20. And I want you to use your common sense. More than that, I want you to have confidence. Believe in yourself. All right? A break, you are scheduled at 1 o'clock. See, my point here is very simple. I am due to give you break for 1.5 hours today. My timings are 10 to 1. All right? 1 to 2 is break. All right? Then 2 to 5. Then 5 to 5:30 is break. So in total, 1.5 hours is what you will get as break. So if you want a break now, I will subtract, reduce that time from some other break. So call is on you. You take the call. All right, then from your lunchtime, I will subtract, I will reduce 10 minutes. If you want a 10 minutes break. Okay, for this also, let me take a poll. Uh, how many of you want a break? Mark A if you want a break, mark B if you do not want a break. अभी मालूम पड़ जाएगा. Mark your answer. 58% do not want a break. Huh? So let us continue. We are just 1 hour 25 minutes to go. You must develop stamina. You have 2 hours of examination, means you should Sit down to study for at least 3 hours. Then only you will develop stamina. All right. Okay. All right. All right. Just refresh yourself. Just refresh yourself. All right. I give you a 7 minutes break. It's 11:35 by my watch. So we meet again at 11:42. Sharp. And I will not repeat a concept if at all you are attending to the class late. I will not repeat it. All right. So 11:42, or let us say 11:43 is when we meet. Okay. So take that break. Come on. All right, can I have you back, captains? All right, I shall inform the concerned person, Aniket. Okay, let's start. Let me just give you a small review. What are integers? They're counting numbers. You have positive and negative numbers. Positive integers are greater than zero, the counting numbers, natural numbers, so as to say. Negative integers are lesser than zero, natural numbers with, let us say, minus symbol on them, so they are no more a natural number, so they are negative integers. And zero is known as neutral integer. It is neither positive nor negative. That is what is the meaning of neutral. Natural numbers are all counting numbers, 1, 2, 3, 4, so on. Whole numbers are 0 followed by natural numbers, 0, 1, 2, 3, 4. All right, so from here to here, these are natural numbers. Okay. Even numbers are divisible by 2, 2, 4, 6, 8, 10, and so on. And odd numbers are not divisible by 2, 1, 3, 5, 7, 9. Prime numbers are those numbers which have exactly two factors. I had written down 25 prime numbers yesterday from 1 to 100. All right. Composite numbers are those numbers which have at least three factors. They're divisible by at least three numbers. Okay. Divisible by at least three numbers like 4, 6, 8, 9, 10, 12, 14, other than this thing 2, 3, 5, 7. That is the prime numbers. But please notice this and know this, that number one is neither prime nor composite. We had discussed this yesterday. Okay, one is not prime, one is not composite. Okay, prime numbers start with 2. This is the smallest and the only even prime number. All right, apart from 2, apart from 2, whatever prime number is going to be there, it is going to be odd. Okay, so apart from 2, each prime number is an odd number. Composite number, as I have written here, they are divisible by at least three numbers. Like 4 is divisible by 1, 2, and 4. Any number 10 is divisible by 1, 2, 5, 10. 14, 1, 7, and 14, and 2 also. Okay, likewise. So that is why they are composite numbers. What does it say? Important formula. So these are important. Okay. This is the most important formula. Sum of initial n natural numbers is n into n plus 1 by 2. So I want you to memorize some of these. Right? This is actually written as sigma n. Sigma means summation. So summation of n natural numbers is n into next number after n plus 1 by 2. So what will be sigma 5? Sum of first 5 numbers. 1, 2, 3, 4, 5. Sum of these 5 into 6 by 2. 2 cancels. It shall be 15. Tell me sigma 10. Sum of first 10 natural numbers. Sum of first 10 natural numbers. Sum of first 10 natural numbers. Come on. Yes, you got this. So this is 10 into 11 by 2 cancels. So it is 55. Tell me sigma 15. Sum of first 15 natural numbers. 15 into 16 by 2 cancels. 15 eights are 120. And tell me sigma 20, sum of first 20 natural numbers. Yes, 20 into 21 by 2, that is 210. Now, sum of squares of n initial natural numbers is n into n plus 1 into 2n plus 1 by 6. You have to memorize this. See, this I can also write it as n into n plus 1 by 2. This you already know. Into 2n plus 1 by 3. n into n plus 1 by 2 you already know here. Okay. So 2 into 3 is 6 and n into n plus 1, 2n plus 1 becomes the numerator. Alright, so let us say sum of squares of first n natural numbers or would be n into n plus 1 into 2n plus 1 by 6. So I want to know sigma 5 square. Sum of squares of first 5 natural numbers. 1 square plus 2 square plus 3 square plus 4 square plus 5 square. It should be 5 into 5 plus 1, 6 into 5 into 2 plus 1, 11 by 6. 6 cancels. It should give you a 55. So what shall be sigma 10 square? What is sigma 10 square? 10 into 10 plus 1, 11 into 10 plus 10 into 2 plus 1, that is 21 divided by 6. So this is, let us say, goes by 3. 3 twos are, 3 sevens are, correct? And this 2 cancels, 10 goes by 5. Okay. So this is going to be 55 into 7. 7 fives are 35, 7 fives are 35, 385. Perfect. Now see sum of cubes of n initial natural numbers. That is sigma n cube. You already know n into n plus 1 by 2. Just square this. Just square this. That's it. So sigma of, let us say, cubes of first 5 natural numbers is going to be 5 into 6 by 2 whole cube. Alright, cancels. Sorry, whole square cancels, goes by 3. So 5 threes are 15. 15 square, that is 225. Sigma 10 cube is going to be how much? That is sum of cubes of first 10, initial 10 natural numbers. That is 10 into 11 by 2 square, 55. All right, and I've already taught you 55 square, 5 6 are 30, followed by 25. Got it? Got it? So these are for starters, just few fundamentals that I've given you as starters. Now, simple question. How many numbers are there from 1 to 50? How many numbers are there from 1 to 50? Tell me. Please tell me. How many numbers are there from 1 to 50? Fill in the poll. Fill in the poll. Fill in the poll. How many numbers are there from 1 to 50? I'm not asking you sum of numbers. How many numbers are there from 1 to 50? Okay, so let me just ask you, how many numbers are there from 1 to 10? Simple question. Type, type, please type fast. 10, obviously. So how do you solve this? So if you have to find out how many numbers are there from 1 to 10, although this is a simple question, what do you do is out of 1 and 10, you know that this is the larger number and this is the smaller number on the left hand side. So you increase the larger number by 1, it becomes 11, and then subtract the smaller number, you get 10. Otherwise, 1 to 10 is very simple, isn't it? So similarly, if you have 1 to 50, you will increase 50 by 1, it becomes 51, and you subtract this one, it is 50. So now you tell me how many numbers are there from 20 to 37. 20 to 37. What will you do? You will increase this number by 1, 38, from which you will subtract the first number 20. So you have 18 numbers. Is this clear? Perfect. 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 So now you tell me how many numbers are there from 23 to 56. How many numbers are there from 23 to 56? Tell me. So 56 plus 1 makes it 57, from which you are going to subtract 23. So you have 34 numbers. Choice B is the answer. Got this? Is this concept understood? Tell me. Give me a yes. Come on. Hurry up. Take the poll. Please answer. Please mark. If you have understood, then yes. A का मतलब yes. B का मतलब no. A का मतलब yes. %98. Lovely. So how many numbers are there from 84 to 129? Tell me. 84 to 129. I'm marking. I'm giving you a poll for this. Mark your answer in the poll. Mark your answer in the poll, please. Please mark your answer in the poll. %95. Lovely. So 129 plus 1 makes it 130. And I subtract 84 from this. Okay. So what I get here is a 46. Choice A. So how many numbers are there from 11 to 99? How many numbers are there from 11 to 99? Please tell me. 11 to 99. Okay, now tell me 10 to 99. 10 to 99. 10 to 99, how many numbers are there? These are what? These are all two-digit numbers. So how many two-digit numbers are there? Perfect. So plus 1, you have 100, from which you subtract 10, so you get a 90. Okay. Now, how many three-digit numbers are there? Three-digit numbers start from 100 and they go up to 999. How many are these? Please tell me. Perfect. So 999 plus 1 is 1000. Okay. Minus 100 should give us a 900. So I hope this is very, very clear. Lovely. Good responses. Now, read the question carefully. How many times digit 2 can be written when numbers are written from 1 to 100? How many times you will have to write digit 2 if you're writing numbers from 1 to 100? So first tell me, are you actually going to write down numbers from 1 to 100? No. So 2, digit 2 will be written in units place and in tens place. Yes? Yes or no? So digit 2 will be written in units place and in tens place. Yes or no? Correct, correct, Brajneet. Correct, Karan. Are Karan, are there two Karans? 20 is correct, 21 is not. Ananya, not 10, beta. Units 9 times, no Subhash. 10 times, beta. No Vikas, not 19. He's not asking you numbers, how many times you are writing. Yes, Dinesh. No, Nitish, answer is not 21. Yes, Dikshit. Alright. See, if you're going to write 2 in units place, which are the numbers? Tell me. 2, 12, 22. Wait. 22, I know it is written twice. Don't worry. 32, 42, 52, 62, 72, 82, 92. So basically these. How many times? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Alright. Now let us see in tens place. Well, you have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So we're talking about these. And how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. Alright. So 10 plus 10 total 20 times. 10 plus 10 total 20 times. So the answer here should be B. No, Dipinder. Tens are not 12, 22, 32. They're not tens, beta. They are units actually. Ha, Prithvi, that is what I'm saying. Now, this is what I'm saying. Prithvi, have a look here. You have the number 22 here. You have the number 22 here. So here I have counted 2 in the units place and here I have counted 2 in the tens place. Because in 22, if you write 22, you will have to write digit 2 two times, twice. Once in tens place, once in units place. So in 22, this gets counted when we are writing units place, when we are counting units place, and this gets counted when we are counting tens place. Okay. Now, listen to me carefully. What if you get another question like this? From 1 to 100, in how many numbers will digit 2 appear? So if he's saying how many numbers, then your answer is 19 numbers. Count 22 as a single number. Get it now? Sian, now you understand. No, Sushmita, but if you write 22, you will write digit 2 twice. Digit 2 can be written. So when you are writing 22, how many times are you writing digit 2? Number will be written once. Every number will be written once. But if you are writing 22, how many times will you write digit 2? You will have to write it 2 times. You will have to write digit 2 times to form the number 22. Now you got this. Sushmita, Sian, Prithvi is saying okay, sir. He's got it. Sian, Sian. Subhash has got it. Sushmita, Sian has got it. Question confused you. So that is why I am telling you, when he's saying written, then in 22, 2 will be counted twice, because when you are writing 22, you will be writing 2 times. Okay. But if he is asking you numbers, then 22 will be counted as one number. Then you will count 22 only once. So I hope this is clear. One time we are considering units place and the other time we are considering tens place. Correct. You got this. You got this. All right. How many times digit 3 will appear when numbers are written from 1 to 500? Appear is same as written here. So how many times digit 3 will be written when numbers are written from 1 to 500? No. Forget about appear. It is written. How many times digit 3 will be written when numbers are written from 1 to 500? Array 100 is not there amongst the choices. Think no. Array Shabash Parshuram. Very good, Shilpa. नहीं रवि चेक करो बेटा. No, Mohammed, you have to give me the count. How many times? Dipinder 40 is not amongst the choices. Yes, Sushmita. No, Madhuri, check. No, Justin, check. Written. Yes, Dinesh. Correct. No, Dikshit. Yes, Tulasi. No, Vikas. No, Ajit. Yes, Nitin. It is not D. It is B. Yes, Usna. No, Sarabjit. Yes, Sakti. Yes, Dipinder, Nitin, Krishna, Mirali, Ananya, Dikshit, Panyala, check. Mohammed, check. Yes, Ravi. Yes, Ajit. Yes, Zainab, check. Yes, Pooja. All right. अरे बेटा अभी तो डिस्कस किया. How many times digit 2 is written from 1 to 100? 20 times, no? How many times digit 3 will be written from 1 to 100? 20 times. How many times digit 4 will be written from 1 to 100? 20 times. So from 2 to 9, each digit will be written 20 times from 1 to 100. But digit 1 from 1 to 100 will be written 21 times, because in 100 also we have 1. So we can say that from 1 to 9 digits, can be written 20 times when writing numbers from 1 to 99. 100 हटाए तो so each digit will be written, each digit, right? Each digit can be written 20 times. So from 1 to 100, digit 3 will be written 20 times. Remember? 10 times in units place, 10 times in tens place. Remember? Now in 500, how many hundreds are there? Tell me. How many hundreds are there in 500? How many hundreds are there in 500? Simple question I have asked you. How can it be 4, Subhash? How many hundreds are there in 500? There are 500s. That is why it is called 500. All right. So it means from 1 to 500, 20 into 5 times, that is 100 times digit 3 will be written in units and tens place. 50 times in units place, 50 times in tens place. So 100 to anyhow you're getting. Now apart from units place and tens place, can't we have digit 3 in hundreds place? So digit 3 will also get written in hundreds place. Remember, 300 to 399. How many times? 100 times. So 100 here, 100 here, 100 plus 100, you should get 200 as your answer. The first 100 is units and tens. The other 100 is hundredth place. Is this clear now? Is this clear? Yes or no? Tell me. Is this clear? Mark your answer in the poll, please. Yes. Come on, guys. Hurry up. 95%. Lovely. Okay, next, let me ask you, how many times digit 4 will be written? From 1 to 500. Shahid, everything is written here. Read, you will get it. You can understand. Again, 200 times. How many times digit 7 will be written from 1 to 500? अब देखता हूं. Himanshu, Hemlata, check. Ambika, check. Shilpa, check. Devinder, check. Abhinav, check. Join, check. Sushmita, check. Deepinder, check. Harihara, check. Rest all got correct. Ramadevi, Ramadevi, check. Dalchan, check. Beta, this time it will be 100 times. 7 is there, no? 7 cannot be written. 7 will not be written in the 100th place. Are 1 to 500 में do you get 700, 701, 702, 745, 799? Then I caught you there. Huh? So how many times 8 will be written from 1 to 100? 8 will be written from 1 to 100. Deepinder, 20 into 5, 1 to 500, 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 1 to 500. How many times 8 will be written from 1 to 500? How many times 8 will be written from 1 to 500? 100 times. Now you got it? Now you got it? From 1 to 500, 1, 2, 3, 4, 5. 100, 200, 300, 400, 500. So we can have only 1, 2, 3, 4, 5 in the 100th place. That too 5 will occur only once in 500. We are not going beyond 500. Okay? Anyhow, good enough. Look at CSAT 2019 question. The number of times digit 5 will appear when writing integers from 1 to 1000. Appear is same as writing. So will be written. Written. You got this now. See, 1 to 1000, there are 10 thousands. Sorry, 10 hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. 1000 is what? 1000. Okay. So, units place and tens place. Okay. So, 20 times in 100. And these are 10 hundreds. So, 200 times. And 100th place directly 100 times. 500 to 599, no? Total 300. Lovely. Now, how many digits are required to write all the numbers from 1 to 1000? Now, before we attempt this question, let us have a brief discussion on the concepts. So, how many? बहुत interesting है and this is not mathematics. This is general reasoning actually, arithmetic reasoning. How many digits are required to write down numbers from now? How many digits are required? There is no 1, 2, 3, 4, 5, 6, right? From, let us say, 1 to 9. If you have to write down numbers from 1 to 9, how many digits do you need? Oh, perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you need 9 digits. And if you have to write down from 1 to 10, how many digits do you need? 1 to 10. How many digits are required? फंस गया नितिन, सुष्मिता फंस गई, गलत, शिल्पा, जैनब गलत, नो शिवानी, नो निकेत, नो शताब्दी, नो पोलकुंडा, नो मोहम्मद, नो पृथ्वी, नो पूजा, नो शिल्पा, नो मोनिका, नो ब्रजनीत, नो रमा देवी, सुष्मिता नो, इवन सॉरी 9 is wrong, नीलिमा नो, राणा नो, सुभाष नो, रागिनी नो, अजीत नो, जैनब नो, हुस्ना नो, नागेश्वर नो, ब्लेसिंग्स नो, सियान नो, दीपिंदर नो, सुभाष नो, ब्लेसिंग्स नो, नितिश नो, हिमजा नो, हिरेन नो, मोनिका नो, तुलसी नो, मोहम्मद नो, केतन नो. या या सुभाष 11. नो ब्लेसिंग्स. अरे क्या कर रहे हो भैया? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then to write 10, you require two digits, no? 1 and 0. What, right? So 9 plus 2, two digits, 1 and 0, no? I caught you there. सही पकड़े हैं. All right. So tell me, how many digits do we require to write down numbers from 1 to 20? 1 to 20. Be careful. मोहम्मद जी, ऐसे कैसे चलेगा? सोनू, सरबजीत, मेघना, चेक. Yes, Dipinder. Sabas. Others are doing guesswork. You're not working. Huh? Doing just guesswork. Just added 10 to 11. What, Ray? See, from 1 to 9, there are 9 numbers. Each has one digit. So, total 9 digits are required. Then, from 10 to 20, there are 11 numbers. Alright, 10 to 20, how many numbers are there? 20 plus 1, 21 minus 10, 11 numbers. Each has two digits, Babu. So hence 22 digits. So total 31 digits. I caught you there. You were simply doing 11 plus 10, 21. What? IAS IPS officer, what are you doing? Huh? Ah. Now you will tell me, from 1 to 99, how many digits are required to write down numbers from 1 to 99? Oh, lovely. Subhash has given a wonderful quote. Think without ink. Very nice. Arey, how 99, Ray? You can see this process that I have adopted here, no? So from 1 to 9, there are 9 numbers. Into each number is one digit number. So you require 9 digits. From 10 to 99, how many? There are 90 numbers. Each number is a two digit number. So 180 here, 180 digits. So total 189 digits. Yeah, now you got this. Now you got this. So now you will tell me, from 1 to 999. How many digits are required to write down numbers from 1 to 999? Come on, hurry up. Wonderful, Sandeep. Very good. Hurry, you're seeing this, no? 1 as it is from above. Okay, so let me just do it once more. And this is the last time I'm doing it. Very last time. 1 to 9. There are 9 numbers and each is a 1-digit number. So 9 times. Then these are 1-digit numbers. So 2-digit numbers are from 10 to 99. These are 90 numbers as is written above into 2 digits. Okay, so 180, 189 till now. Now from 100 to 999. These are, remember, 900 numbers and each is a 3-digit number. So 2700 here. So I want you guys to memorize this number. Please memorize this number. Okay. So what you can say here now is to write down numbers from 1 to 999. Total 2889 digits are required. So can you memorize this for me right now? 1 to 999, 1 to 999. There are 2889 digits required. 2889, 2889, 2889, 2889, 2889, 2889, 2889. Please repeat with me. 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889, 2889. So from 1 to 999, if you have to write down all the numbers, you require 2889 digits. Is this understood? Tell me. Very fast, please. Please tell me. Come on, guys. Is this understood? Did you become the understander of this? Yes, Subhash. A ka matlab yes. Wonderful. You got 98%. Lovely. So, this was important. Now, look at this question. How many digits are required to write all the numbers from 1 to 1000? You already know from 1 to 999 how many digits are required? 2889, 2889, 2889, 2889. And for 1000, writing down 1000, how many digits are required? 4. Yes, sir, you got this. Wonderful. So from 1 to 999, we require 2889 digits. All right. And for 1000, if you want to write down 1000, you require 4 digits. So in total, 2893 digits are required to write down numbers from 1 to 1000. All right. So I hope this is very, very clear. So let me mark the choice here, 2893. How many digits are required to write all the numbers from 1 to 3024? Try to solve this. Come on, try to solve this. Yes, correct, Dikshit. It is similar to if there are 200 pages in a book, how many digits will be printed? Correct. So this is actually meant for such kind of questions. All right, sir. So from 1 to 999, anyhow, you require 2889 digits. Now from 1000 to 3024, huh? How many numbers are there? From 1000 to 3024, 3024 plus 1, 3025. 3025 minus 1000, that is 2025. Into these are 4-digit numbers. Okay, so this is equal to 8100. Okay, so 10989 is the total number of digits which is required given to you in choice B. Now, is this understood? Please tell me. Pooja, 1000 to 3024, there are 2025 numbers, no? Remember? 1000 to 3024. How many numbers are there? Plus 1. So 3025 minus this 1000. So that gives me a 2025 numbers. And each of these is what? These are 4-digit numbers, no? To write down 1000, you require four digits, no? 1000. All right. So every number from 1000 to 3024 is a 4-digit number. So total digits required will be 2025 is the count of numbers into 4 digits, 8100. So added these two, I got 10989. Correct. Yeah, what was the this thing? Yeah, I'm giving you Akshay. You're enjoying it. I think you're enjoying it, isn't it? Okay. Let's start with CSAT 2019 question. Now this is a little bit ulta. Initially we found out from 1 to 3024 how many digits are required. This time digits are given to you and he's asking you how many numbers can be made. If he says how many pages does the book have, how many numbers can be made? Pages will be numbered only, no? So what is the total digits? See, number given to you is also a very easy one. Because this CSAT guy wants you to remember 2889. So he's given you a 3089 for ease in subtraction. So now from 1 to 999, how many digits are required? 2889 digits. Okay. So how many digits are remaining? 200, no? Yes. And you have marked the pages of the book till 999. All right. Now after 999, the next page number will be 1000. So followed by all 4-digit numbers. So after 999, what will be the number? 1000, then 1001, 1002, 1003, 1004, 1005, 1006, and so on. Yes. So, how many 4-digit numbers can be formed with 200 digits? Tell me. अरे simple रे. 50 only, no? So initially you have marked numbers till number of the pages till 999. Okay, till 999 you have required or you have used 2889 digits. Now you are left with 200 digits. With 200 digits you can form 50 more numbers which are 4-digit numbers. Alright, so what will be the page number, last page number? 1049. C is the answer. Correct, Asif. Correct, Subhash. Yes, Ananya, Sandeep, Sanika, Akshay, correct. Yes, Nitin. Yes, Shivani, you got it. All clear? So simple enough, no? Actually. So that is the importance of 2889. See, you directly jump from 1 to 999. You did not have to calculate separately for single digit, 2-digit, 3-digit. You already remember the sum of digits required to write down numbers from 1 to 999, and that is 2889. So that is why the length of the question has decreased. So what did you do? 3089 digits are available. 2889 will be utilized to write down numbers from 1 to 999. 200 digits remaining will form now 50 numbers of 4-digit numbers. So 999 plus 50 should give us a 1049. Read once, please, when you wrote from after 999. After 999, the next page number will be 1000, followed by all 4-digit numbers. So how many 4-digit numbers can be formed with 200 digits? अरे बाप रे, इतनी गंदी handwriting है क्या मेरी? Okay, let me copy here if you want. Now I think it should be legible. इसे हटाया था मैं. अब हो गया गुडी गुडी यम यम. चलो. On one side of a 100-meter long road, 11 roses are planted at equal distance from each other. Now, what is the total distance between 3 consecutive roses? Now, I want you to know that if there is, let us say, there are 2 roses, they form one gap. So, between second and the third, you have another gap. Between third and fourth, you have another gap. Okay, so this is again one gap. This is again one gap. So total number of roses are 4. I'm giving you an example. All right. So total roses here are 4, and total gaps or distances are 3. Yes. So from this, what we gather is number of gaps will always be equal to number of roses minus 1. So 4 roses, 3 gaps, 5 roses, 4 gaps, 100 roses, 99 gaps, 50 roses, 49 gaps. Clear? So 11 roses means how many gaps? Tell me. Please tell me very fast. All right. So total length is also given to you. Okay. Total length of the road is also given to you. That is 100 meters. Okay. So one gap will be equal to total length by total gaps. Total length is 100 meters. Total gaps are 10. So one gap is 10 meters. Okay. So 3 consecutive roses. If there are 3 consecutive roses, 1, 2, 3. How many gaps? 2 gaps. No? 3 consecutive roses means 2 gaps. Okay. So 3 consecutive roses means three minus one equal to 2 gaps. Yes. So here total distance shall be 20 meters. Zainab, the answer is already out. 20 meters. You are multiplying 3. 9.09, how you are getting? Why are you dividing 100 by 11? See, when I'm explaining the question, kindly be with me. No, don't solve it on your own. Now look at this. Look at the screen. Everything which is there. Just look at it for clarity. सुभाष जी का आंसर बिल्कुल ठीक है 100/10 is 10 each between 3 rows is 2 gaps so 2 into 10 20 करेक्ट है बिल्कुल 100%. क्या बात है भाई छा गए क्या बात है वरना छा गया भैया अरे तुम हिंदुस्तान की होप हो तुम तोप हो चले जी. Now let us solve CSAT 2022. Read the question. On one side of 1.01 kilometer. Now you should know that 1 kilometer equals 1000 meters. 101 plants are planted at equal distance from each other. So number of gaps or number of distances is going to be 101 minus 1, that is 100. Okay. So 1.01 into 1000 divided by 100 is the length of one gap. So that is 1, 0, 1, 0 by 100. That is 10.1 meters. Now, what is the total distance between 5 consecutive plants? 5 consecutive plants means 4 gaps. All right. So required distance is 4 into 10.1, my dear, and that is 40.4 meters. A का मतलब yes, B का मतलब no. समझ में आया भाई? A का मतलब yes, B का मतलब no. Please, please, please. Kindly mark the poll. Have you understood this type or pattern of questions? Please mark in the poll. 95%, lovely. अरे बाप रे का डरावना क्वेश्चन है. If 20 into 19 into 18 into 17 into 16 वगैरह 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 into 3 into 2 into 1 is 2 raised to m into n, where m and n are positive integers, then what is the maximum value of m? Maximum value of m is what? Power of 2. So he wants to know how many 2's are there. How many 2's are there in this multiplication? Are you really going to multiply all these numbers? Obviously not. Okay. So then what will be the highest power of 2 in this multiplication? Okay, because he wants maximum value of n. Absolutely yes, Subhash. We only need to look for multiples of 2. नहीं अक्षय, none of these, because you're not able to solve. ऐसे कैसे चलेगा मेरे भाई? देखो ना. So tell me which numbers will have 2 as a factor? Even numbers only. Even numbers. All right. Only even numbers will have 2 as a factor. So let us write down all the even numbers. कौन से हैं? 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. These are the only even numbers, no? Odd numbers will not have 2 as a factor, no? Odd numbers will not be divisible by 2. That is why they are odd numbers, no? So now factorize. Please factorize. You learned factorization yesterday, no? LCM. 20 is what? 4 into 5. Yes? 4 into 5. So can I write it as 2 square into 5? Huh? So how many 2's do we have? Look here, no? How many 2's do you have? 2 2's. Number of 2's, that's all that we need to find out. 18 can be written as 2 into 9. This is 2 power 1. So how many 2's do you have here? Only 1 2. Only one time. 16 you should know is 2 to the power of 4. 2 to the power of 4. So how many 2's do we have? 4 2's do we have? 14, 2 into 7. So 2 power 1 into 7. So you have a 1 here. 12 को कैसे लिखोगे? 4 into 3. 4 into 3 means 2 square into 3. So how many twos here? Two twos here. How do you write 10? 2 into 5. So 1 2 here. How do you write 8? 2 cube. So 3 twos here. 6 is 2 into 3. So 2 power 1. 1 time 2 is written here. 4 is 2 square. So there are 2 twos. And 2 is written as 2 to the power of 1. So there is only 1 2. Please count. 2, 3, 7, 8, 10, 11, 14, 15, 17, 18. Choice B should be the answer. Yes, Shivani, look at this question. If 20 into 19 into 18 and so on is to be expressed as this 2 raised to m into n, that is 2 raised to m. You have to find out the maximum value of m. M here is power of 2. What is m? Power of 2. Okay. So how many 2's are there in the given numbers? Where are 2's as a factor? All right. Only even numbers will have 2 as a factor, no? So I have written all the even numbers in this multiplication. Which are those 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. And I factorize them to find out how many 2's are there. In 20, there are 2 2's. 4 into 5. 4 is what? 2 square. Now similarly, 18 has 1 2, 2 into 9. 16 has 4 2's, 2 power 4. So in every number, I am taking the power of 2. I'm counting the powers of 2. So there are 18 2's basically. So the maximum value that m can have here is 18. There are 18 2's. Two, 3, 7, 8, 18. Where did I write that? Achha, 2, 3, 7, 8, 18 means I'm just counting the number of ones, number of twos here. That's it. That's what I did. I've just counted these and I've written the counting here. No, Ambika, this is not IIT JEE. All right. No, simply find out how many twos are there. So that means you are going to factorize it. So have you understood? Have you understood this? A का मतलब yes, B का मतलब no. बताओ भाई. %97%. Yes, Akshay. We need to break the way if number is 2 base m plus n, then we will for addition numbers. I did not get you. We will के बाद में नहीं समझ में आया यार. We will I for addition numbers. I did not get you there. Pooja, where were you? So many times I have repeated. It is written here. Only even numbers will have 2 as a factor, no? Odd numbers are divisible by 2. They are not. That is why they are odd numbers. Even numbers are divisible by 2, no? Huh? Odd numbers will not have 2 as a factor because they are not divisible by 2. Is 7 divisible by 2? Is 5 divisible by 2? Is 17 divisible by 2? Is 19 divisible by 2? Do they have 2 as a factor? No. Okay, now attempt this. अब आएगा मजा. अब तो आसान लगना चाहिए. CSAT 2022. But this time you have 3 to the power of m. So you have to find out how many 3's are there. So what should you do? You should take multiples of 3. Tell me, which are the multiples of 3 here? From 15 to 1, 1 to 15. Which are the numbers which are multiples of 3? Please tell me. Correct, Blessings. Correct, Parshuram. Correct, Akshay. Yes, Shahid. Huh. Subhash is telling me the numbers. You people are not telling me the numbers. See? Multiples of 3 I asked you. 15, 12, 9, 6 and 3. So find out how many 3's are there. What is the issue? This is 3 power 1 into 5. This is 3 power 1 into 4. This is 3 square. This is 3 power 1 into 2. This is 3 power 1. Count the number of 3's. So 1 here, 1 here, 2 here, 1 here, 1 here, 1 plus 1, 2 plus 2, 4 plus 1, 5 plus 1 is 6. That should be the answer. Clear? Got it? आगे बढ़ते हुए भैया. See, varieties of questions. All these questions you might not have seen ever. But then, if you use common sense and the basics, very basic principles of mathematics, you will be able to solve them. Integers are listed from 100 to 400. Are you going to write down numbers from 100 to 400? No. You will just use your common sense and choose some numbers. In how many integers is the sum of the digits equal to 5? That means if it is a 3-digit number x plus y plus z, 3-digit number x, y, z, then the sum of the digits should be equal to 4. In how many numbers is this like? Hundreds, let us find out. In 100, you have numbers like 100, 101, 102, 103, 104, 105, 106, 107, So there are 3 digits here. And you know that the first digit is 1. Okay. So second digit will be x, let us say. Third digit will be y. And sum of these digits should be equal to 4. Say what? So this means that x plus y must be equal to 3. Because 1 is already there, no? So the sum of x and y must be 3. So that 1 plus 3 is 4. So take values of x and y. Start from 0. X is 0. Then y will be 3. 0 plus 3 is 3. X is 1. Y will be 2. 1 plus 2 is 3. X is 2. Y will be 1. 2 plus 1 is 3. X is 3. Y will be 0. 3 plus 0 is again 3. So how many values do we have here? We have 4 values. Okay. So we get 4 integers, no? If you want, you can put 1 to the left, no, every time. 103, 112, 121, 130. Now let's have a look in 200s. So 200 something, it will be 2 plus x plus y. That should be equal to 4. Correct? So which means that x plus y must be equal to 2. 4 minus 2 is 2. So start with 0. So if x is 0, y will be 2. 0 plus 2 is 2. If x is 1, y will be 1. X is 2, y will be 0. So there are only 3 numbers which are possible. 202, 211, 220. Yes, the sum of the digits is 4. See 300s. 3 plus x plus y should be equal to 4. That means x plus y must be equal to 1. Yeah. So 0, 1, 0 plus 1, 1 plus 0. That's it. So you can have only two numbers, 301, 310 in 300s. Okay. 400s, well, you have only one number, no? 4 plus x plus y is equal to 4. So x plus y is 0. So you have only one number, no? 400. So here 2, here 1. So 4 plus 3 plus 2 plus 1 should be equal to 10. Choice C is the correct answer. Yes, Subhash, you have written the numbers, but the whole point is you might forget some number. So better, do it properly in a method. But good you that you could identify the numbers. Yes, Dikshit, correct. Yes, Himanshu. Ah, see, Akshay, you missed 121. So that's why I'm saying just take the values here in a proper order. You will not miss anything. You know? Because 9 is also there in the amongst the choices, no? So if you miss one, then you will mark 9 as the answer. All right, sir. Solve this question from CSAT 2021. Now integers are listed from 700 to 1000. In how many integers is the sum of the digits equal to 10? See, in previous question, the sum of the digits was 4. Here the sum of the digits is 10. So can you find out? Again, 700s you should take. So 3-digit number will be 7xy. So it should be 7 plus x plus y. The sum of the digits should be 10. That means x plus y should be 3. Now which two numbers add up to 3? Well, 0, 3, 1, 2, 2, 1, 3, 0, 4 numbers. In 800s, it is 8 plus x plus y, which is equal to 10. Right? So x plus y equals to 2. Take values. 0, 2, 1, 1, 2, 0. So 3 values in 800s. See, here you will have 703, 712, 721, 730. Here you will have 802, 811, 820. Let's talk about 900s. So 9 plus x plus y is equal to 10. Then x plus y is equal to 10 minus 9, that is equal to 1. So 0, 1, 1, 0, 2 values. Khatam bas. Don't take 1000 as 10 plus 0, 0. And as it is, 9 is the highest choice, no? You don't have any. See, that is a point. Sakti, do you have 10 amongst the choices? Sakti, do you have 10 amongst the choices? The highest choice only is 9. Thank God 10 is not there. Otherwise, you would have got your answer as 10 and earned minus 3.33. Dikshit, in 700 it is 4, then in 800 it is 3, then in 900 it is 2. So one is decreasing each time. Correct, correct. Good observation, Dikshit. All right, Sakti. Okay, you got this. Now using 1122 as digits, you have only 4 digits. 1, 1, 2, 2. That's it. How many distinct means different numbers greater than 2000 can be formed? Arey, this is a very simple thing, no? 4-digit number. Okay, it is greater than 2000. Means which digit will come here? 1 or 2? Which digit will come or which digit will be placed at the 1000th place? Absolutely. So you have only one option. 2. Now what are the other letters left? 1, 1 and 2. So you can have 2, 1, 1, 2. 2, 2 1 1 and 2 1 2 1. That's it. Only three over. Which is the fourth one, Akshay? बोलो भैया. Pooja, what is there? See, it is greater than 2000 and you are given only 1 1 2 2. If it is greater than 2000, then obviously you will have only two here, no? You can't have one. You can't start a number with 1000 if it is greater than 2000. 1000 is not greater than 2000, bro. So it has to start with 2. What are the other digits left? 1, 1, and 2, because this you have used here. So I can now make numbers, no? You can make numbers with 1, 1, 2, no? 2, 1, 1, 2, 2, 2, 1, 1, 2, 1, 2, 1. That's it. Just by changing the places of 1, 1, 2, you made three numbers. Silly mistake, yes. Yes, 2112 is also greater than 2000. So that is the first number I wrote here, Sushmita. 2112. It is there. I have not missed on any number. See? These are the three. Now let us solve the question that was asked in CSAT 2021. Using 22333 as digits, how many distinct numbers greater than 30,000 can be formed? Greater than 30,000. Very good, Parshuram. Very good, Shahid. Very good, Rajneet. Very good, Dikshit. Very good, Shivani. No, Dipender. Very good, Sian. Very good, Usna. No, Bageshwari. Mageshwari. Yes, Blesslands. Very good, Sandeep. No, Meghna. Yes, Ravi. No, Pooja. Yes, Yera. Yes, no. एक minute. Yes, Ananya. Yes, Harihara. Yes, Shilpa. Ashish. Now correct, Mageshwari. No, Rana. Yes, Sanika, Susmita, Ashish, Pulakonda, Nitin, Akshay. Not probability, Gaurav. Just remind me, I will be solving this question using permutation and combination. Permutations. Combinations we can use there. Permutations only we will use, we will get the answer. I will teach you when I will take up permutations and I will, take this question again. Yes, join. Yes, correct, Tulsi. Sarabjit, correct. Yes, Panela. Yes, Asif. All right, let's have a look at the numbers. If the number is greater than 30,000, then for sure this place we'll have to have 3 because 22333. So the number is greater than 30,000. I can't have 2 here. Then the number will become in 20,000s. 20,000s is not greater than 30,000. So we have already utilized 1 3 here. Okay. So each of the numbers that I'm going to make, first digit is going to be 3. Now 2233. I'm using the pair of double 2 first. So this is again to be done in an orderly fashion. So first I'm putting 2 2s. So 3 double 2, 3 3. Push double 2 to the right side. 3 3 double 2 3. Again 3 3 3 double 2. All right. Now let us make use of single ones. So I can have, let us say 3 2 3 2 3. 3 2 3 3 2 and 3 3 2, 3, 2. Okay. So these are the 6 numbers. If you miss any one of them, then that is still fine. If you're getting 4 numbers, also your answer is going to be 6. Right? If you get 5 also, answer is 6. Okay, so be careful. Perfect. Perfect. All right, guys. So we break for lunch. It's 109. 107 is when I was supposed to give you. So we meet again at 202. Fine? Or why 202 there? 2 o'clock only we will start. So that 2 minutes I can include somewhere else and give you a break later on. Okay? So let us utilize our time. 2 o'clock we are meeting. Have lunch. Don't have heavy lunch. Okay? So that you sleep in between. Don't do that. Question of your career and life. Okay? So break for lunch. 2 o'clock is when we meet. ठीक है जी? Yippee, मिलते हैं ब्रेक के बाद.